Okay, great. So guys, welcome to this YouTube tutorial. We'll continue with subnetting. So I'll be doing question B1 and 2. Question 2, B1 and 2. So the question says, the network below shows a network connected via cloud and serial links with the IP address which you have been given, as you can see. So we are saying use static routing to enable inter-network communication. So this is the topology which you have been given. So now the first step, we need to identify the type of network which you have been given. So in this case, take note that we are using static routing, meaning the subnet mask we will not change. It will remain the same throughout the entire network, because here we have been given branches. We have branch 1, branch 2 and the main. So now with that said, let's just copy this network which you have been given. So this is the network. /26. So now this class is class C. From the look of things, we can see that this is a class C network. Okay, so now the subnet mask for this network, subnet mask will be 255.255.255. So here I've been given 26 bits which represent number of subnets which have been given. So in this case, for us to identify these bits, we would say, so the first octet has how many ones? 8 ones. The second, 8 ones as well. The third, 8 ones as well. So these ones, when you add them together, they are giving you 255, because here it will be 28, this one to be 64, the third one 32, this one 16, this one 8, this one 4, 2 and 1. So when you add all this, it's giving us 255. So how many bits do we have here? So we have 24 bits altogether. So in order for us to reach up to 26, how many bits are we supposed to add? So from 24, 25, 26. So meaning we have added 2 bits for us to have 26. So the remaining will be zeros. Okay, so this is how you can as well represent the subnet mask in binary. So meaning when we add this 128 here and 64, it gives us 192. Okay, so this is the subnet mask for this entire network. This is the subnet mask in binary. It's like this. So the number of hosts in which we can assign to this particular network, we have 6 bits. We have 6 bits. So we'll just say 2 to the power 6. Okay. Then that will give us the number of hosts we can assign. So now if we say 2 to the power 6, it gives us 64. Then we subtract 2 from 64. So the first one which we're subtracting, it's for the network address, and the second one is for the broadcast address. So we remain with 62 valid hosts in this particular network. Okay, so this is the data which we have. This is the type of network which you have been given. So now we have 3 branches. Take note, in this diagram or topology, we have 3 branches. We have branch 1, 2, and the main. Okay, so let's start with the main. So here we have main. So for the main, we can start assigning IP addresses. Okay, but in order for you to have a very good understanding on this particular network, I can create a subnet, a VOSM table, so that you can have a very good understanding. Okay, so I'm just creating a VOSM table. So this is just basically a VOSM table. So here we have the number of block size. Block size. Then we have CDR, crossless in the domain routing. Then we have the subnetting mask. Okay, so now the block size always starts from 1, 2, 3, 4, 8, 16, 32, 64, and 128. Basically, you might ask yourself, okay, where are these numbers coming from? So we know from those binary digits, from these ones, we know that basically in computer we use base 2, right? In computer we use base 2. So we have how many 2's? We have 8 2's, okay, in this first octet. So the first one, it will be to the power 0. Okay, so the first one, it will be to the power 0, 2 to the power 0. Okay, so let me just pause this video. Okay, so as I was saying, we know that where are we getting this block size from? You can ask yourself this particular question. So what we need to know is that computer basically they use base 2. Okay, they use base 2. So now here what we did is that each 2 is powered to the first one, it's 0. So we say 2 to the power 0. So 2 to the power 0, it's 1. 2 to the power 1, it's 2. 2 to the power 3, it's 2 to the power 3. 2 to the power 2, it's 4. 2 to the power 3, 8. 2 to the power 4, which is 6, 16. 2 to the power 5, 32, 2 to the power 6, 64, 2 to the power 7, 128. So this is where this block size is coming from. After that, we can now create what we call the VSM table. So here we have 32. Okay, here we have 32. So VSM table, we're basically subtracting with 1. Subtract with 1. Okay, then here subtract with 1. So the second one to be slash 31. So let me just pause the video so that we avoid wasting much of the time. Okay, so as you can see, I'm done. So this basically, these slashes they basically represent the number of hosts, the number of bits. Okay, the number of bits in each block size. So as you can see, here we have 25. So the default one, you need to take note that the default one, let's see, slash 24. Okay, the default one is slash 24. So here we add 1 when it becomes 25, meaning the block size it will be 128, because we have only added 1 bit, the rest will be zeros. So this is why it's 128. Then now we've added another bit when it becomes 26. When it becomes 26, meaning the bit is here. Okay, this one becomes 0, so the bit is here on the second octet. Okay, so this is how it works basically. This is how it works. So now for default subnet mask, it's 255.255.255.255. Sorry, .0. So as you can see here, we have 8 ones, again 80 ones. So these ones in each octet, they reach up to 24. So this is where this 24 is coming from. Okay, so this is the default subnet mask for class C. So since I've said we've just added a 1 to 25 to 24 for it to become 25. So meaning the subnet mask for 25, it will be 255.255.255.128. So why 128? Because we have just basically added a 1. Okay, the rest are zeros. The rest 7 bits will be zeros. We have added a 1 to what? To 24. Okay, I've added a 1 . Okay, so this is 1, 2, 3. Okay, so I'm not 0 here. Okay, so that's how it works. So this is 28. This is K1A which we have added. So on 26 here, it will be 255.255.255. It will be dot what? So again, don't forget that concept. So meaning in binary we have added another 1. So meaning it will be 1, 1. Because this is 26, so I've added 2 ones. Then the rest will be zeros. So when we add, this is 128. Okay, then this is 64. So 128 plus 64, it's 192. Okay, 192. So this is how how it works, basically how you can create a VOSM table. So let me just pause so that I can just do it in a quick way. Okay, so as you can see, this is how it looks. So it looks something like this. Okay, so this is how you can create a VOSM table. So the reason why I'm creating a VOSM table is that for us to make it easy to know the number of to know the block size which you need, to know the subit mask. It will be easy. So it is just making our work very easy. So this is why it is very important to come up with a VOSM table. So now let's go back to our topology. So this topology of ours, it has 3 branches. So let's start with the main, as we can see on this diagram here. So we're starting with this. We're starting with the main. Okay. So this main, we have the IP address here. So we need to give it the IP address. Okay, so this main has this network address. Okay, so this is the network address. Okay, range. So this basically when it will just range from since I've been given 26, so /26 will just come here where there's /26 here. So meaning the block size it's 64. The block size it's 64. So meaning don't forget that you'll be removing 2 in terms of for us to find the valid host. We'll remove 2. So meaning the valid host will be 62. So okay, so this is 64. This is the block size. So meaning the IP address will range from 0 to 192.168.20.63. So the reason why I've written 63 is because I've removed a 1, which is the broadcast address. Okay, so we must always remember to remove a 1 for the broadcasting address. So in this case, meaning the branch 1 in this topology, branch 1 will have the IP address of the IP address range of 192.168.20.64. So we start from 64, then 192.168.20. So we just add the 64 plus 64 because it is graceful, so just keep on adding 64. So 64 plus 64 it is 128, so just say 127. So that the next branch, which is branch 2, address range to be 192.168.20.128 to 192.168.20. So 128 plus 64, which is 192. So just a 191. So we need to also take note of these routers. Okay, we need to take note of these routers as well. So this router and this router, and this router is supposed to have IP addresses as well. So you can just say router's IP address. So the IP address for this router 0, we'll say so IP address range starts from 192.168.20.192 because we ended on 191 to 192.168.20. So 64 plus 192, which is 256. So we move the 2 for the broadcaster network. So it will be 254 because 254, this is the maximum IP address we can assign to a particular device. Okay, so with this done, as we can see, we've created the ranges. So we have branch 1, branch 2. So now let's separate these branches. We just separate them. Okay, so let me start with branch 1, signing the IP address. So for the branch 1, meaning the varied hosts will be 64 minus 2, which is equal to 62 valid hosts. Okay, so the valid hosts will be 62. Okay, so let me just write 62 here. And now for the first device in which you can assign, or before even talk about the first device in the main, we can say the default gateway. So the default gateway, it will be 255.168.20.1. Okay, so we need to take note of this range because the IP address starts from .1 up to 62. So now the first PC will be assigned with IP address 192.168.20.2. Okay, so in this case our subnet mask 255.255.255.192. So our subnet mask basically this is our subnet mask. It never changes because we're using static. Okay, we're using static. So here you can say basically this is for the main branch. So I'll just basically do the same with the remaining branches. Okay, so this is for the main. So now even in branch 1, I'll do the same thing. Okay, so as you can see here, just doing the same thing. So meaning the varied host, it will be 62. a default gateway in this case it will be 65. Assigning PCs 66 going up to 126. Then this is a subnet mask, and we're done. We'll do the same to branch 2. Okay, do the same to branch 2, whereby 129 is our default, then 130 going up. Start assigning the PC from 130 going up, then we are done. Okay, this is simple and straightforward. And now on the routers, since we have 3 routers, then okay, we've just given a range of these routers. Okay, so meaning the first router for the main, it will be 192.168.20.193. So for branch 1 it will be 194. Then now for branch 2 it will be 195. Okay, so simple and straightforward. Okay, so this is for the routers. Okay, so basically the VSM table looks something like this. As you can see, we have the main, branch 1, branch 2, and the IP addresses for the routers. So now let me just open up Cisco. Okay, so here with Cisco, this is now where we can implement our topology. Okay, so I'll be just implementing our topology. Let me just pause the video. Okay, so as you can see, this is our topology will look like. Okay, as we can see from this particular diagram here. So now we can just start connecting with the preferred cables. So the first one I'm connecting to first Ethernet 1, then just connecting the cables here. So you can just follow me as I'm connecting the cables. So you need to take note of all these interfaces. You need to know that, okay, I've connected to this particular interface. Okay, so now here we're using 1. Yes, here we're using 1. So this first one goes to here. Then serial 1 goes to branch. Then serial 2 goes to serial 2. So okay, so now we can start assigning these devices, network devices, with IP addresses, including the PCs. I can just start assigning with the IP addresses. So now we start with the main. So here from the main we can see that this is the IP address .2. We just copy it, then we come to this main PC. Okay, this guy paste it. So the IP address is 92 is 1. Okay, so the default gateway as well, which is connected to fastnet 0. Also, don't forget the default gateway for this network, which is .1, then 192. Turn it on. As you can see, it's now on. Then we come to the second branch. So branch 2. So here from the question, before I talk about branch 1, you can see the question is saying that we need to also there will be a need for us to block this IP address, which ranges in .70. So .70 will be blocked. So as you can see, .70 can be assigned within this particular range of IP addresses, because the IP addresses starts from 66 going up. So we'll just deliberately assign this particular device with .70. Okay, so let's copy. Okay. So the IP address 192, then the default, which is 65 for branch 1. This is branch 1. So here on this router which belongs to branch 1, also include the default gateway so that we can enable communication between these two. Okay, it's on. So the last branch, which is our final branch, having the IP address .130, branch 2. So just assign it as well. 192. Okay, so the IP address will be 129. The default gateway 129. So the default gateway is particular device, which is in fastnet 0/0. So 192. Can turn on. Okay, great. So now let's assign as well to the these routers. So the first router for the main has the IP address .193. So we come to this main router. So this main router is connected to port what? Port 2, serial 2. It's connected to serial 2. So come to serial 2 here. You just basically paste and turn on. Okay. We come again to branch 1, so which is .94. So branch 1. So branch 1, it is connected to serial 2. Okay. Turn on. So the final branch, which is branch 2, also assign using this serial 2. Turn on. Okay, perfect. So now with this done, our next step will be there will be need for us to appreciate this frame relay, which we basically have here. Okay, because these routers at this moment they do not know about this frame relay. They don't know that they are connected via a cloud and using frame relay protocol. basically a frame relay, this is just a standardized one protocol which can just connect multiple networks over a long distance, like the way it is doing right now. So this is just a protocol in the cloud, in this cloud. So now these particular routers, these three routers, needs to know about this frame relay. So just go in one of these routers, any, you can just choose between these three. Go inside this router, go to the command line interface, then from scratch you can just press exit, you can press exit, okay, enable, then conft. Okay, so now here we'll just go to the interface. So I've connected to which interface for this port? So interface 2, serial 2. This is serial 2. So just go inside this serial 2. Okay. So in serial 2 we just say int f int s2/0 in. So now if you don't want to do, if you don't know anything, you can just press a shift then question mark, it will guide you. So we'll be using encapsulation, so just say en then tab. So you can also add the question mark here. So as you can see, we are using frame relay networks. So here we basically say frame relay. So upon you typing this particular command, you can just press enter. Okay, so as you can see, the line protocol, this interface is now up. So upon doing that, there will be a need for you to assign a opposite IP address. Since we're in this router, we need to assign, in this router, assign an IP address for this main router. Okay, so what we do now here, we'll just say frame question mark. So here you can just say question mark. So we are mapping, as you can see here, we are mapping a protocol. So map, then if you don't know anything, just press question mark in IP. So IP, which IP? So 192.168.20.193. Okay, so remember where the 193 where it's coming from. As you can see, for the main branch, this is the 193. This is where it's coming from. Okay, so 193, which has been assigned in this serial port, not the default gateway for this, no, but the serial. So after that, you can just press question mark space, then question mark if you don't know anything. Then you can just choose any number from 16 to 1007. Then you can even press question mark again. So you can choose any. In this case, I'm choosing Cisco. Then I can even broadcast. Okay, I can even broadcast. Okay, so press enter. So basically we are done. Okay, this is what you are supposed to do. Then now, since we have assigned an IP address using frame relay in this particular router, using this particular IP address, so we can just open up the links so that these remaining two routers know about this frame relay. They need to know that, okay, there is a frame relay which you'll be using for communication. So go inside this main router, then command line interface. So just press exit here. Exit. Okay. So inside the router, so which is serial2/0. Then you can say en, then fr tab, then so it's up. Okay, it's supposed to be doing something like this. It's up, so nothing else. So now it knows that okay, there's a frame delay which you'll be using. That's all, nothing else. So we do the same thing. In this router, branch 2. Okay, do the same thing. So I'm in global configuration mode, int, then s 2/0, enter, then en, then family. Okay, it's up. Okay, so this is perfect. Now we can move on. So after doing this, the next thing you're supposed to do is supposed to go inside this router. Okay, inside this router, sorry, not the router but the cloud. Inside this cloud, then now we'll be specifying the interfaces. Okay, so we need to know that this router, the main router, is connected to the cloud via serial 0. So let's go to serial 0. Then here we can select the same number which you selected, which is 16. But the number 16 which we selected basically was in what? In router 1. Because in router 1, that's where we selected 16. That was 17, so to say. So let's go in router 1, in serial 1. So this is serial 1, because there's a number which you selected here, which was 17. If you remember, inside this router, this number, we selected this number 17 in this router, this 17 here. Okay, so now what we do, we basically go in this cloud, then we go in serial 1, because this router, the main router, okay, the main router in branch 1, the branch 1 router is connected to the cloud. Branch 1 router is connected to the cloud via serial 1 interface. So in serial 1 interface, then here 17, then the name. So it's coming from branch 1. So I'll just say B1 to main. So going to this direction. Okay, B1 to main. So we can add. So we can select another number, 18. Then we can say B1 to branch 2. So B1. Okay. So we need to select all the sublinks here, or creating the sublinks. So B1 to M, again B1 to B2 to branch 2, so to say, we add. So we go to this, after we're done with that, let's now go back to 0. So since we ended on 18, we can just say 19 here. Then here, since we're now in serial 0, and see which router is connected to serial 0. So the router which is connected to serial 0 is the main router. Okay, so here starting with M, it is the main router which is connected to 0. So we just say M to, so M to what? To B1. M to B1. Then we add. Again here we can just say it's 20. So we say M again. M to what? To B2, to branch 2. We add. That's all. Now let's go to the serial 2, the last interface, serial 2. So this serial 2, the router. So the branch 2 is connected to serial 2 via this cloud. So we say, okay, so here we say we can just give any number, let's say 21. So we say B2. Okay, since we are now connected to this via serial 2, we say B2 to B to M to main. So this one to main, right? Then we add again. You can change the number 22. Then you say B2. Okay, B2 to B1. B2 to B1. We add. Okay, great. So now, since we are done with adding, we can now go to the family then. Let's go back to the family then. So you have 0, 0. So 0, 0, which is this in the main router, 0, 0. M, as you can see, 0, 0 equals the sublink, which is what? The port 0, 0, and then the sublink is M to B1. So 0, 0, M to B1. Again 0, 0, M to B1. So here is supposed to change. So you can put 0, 1, this one, so that it can be B1 to M, the opposite way. Okay, the opposite. So you have created. So we can change. Say we can say again M to B2. Okay, so M is M, the main to B2. Again here we can change. We can say B2 to M, so vice versa. Okay, B2 to M. So now we can change another interface here. Let's go to 1. So we can say B2. Okay, so 1 branch 1. So B1 to B2. B1 to B2. Again here you can change. Here we can say B2 to B1. So this is just basically the opposite. Okay, so we are done with the links. As you can see here, we have M. How many M's do we have? 1, 2, 3, 4. Okay. Then how many B's do we have? 1, 2. Okay. So these are the links which we have created. So again, we can say this is B1 to B2. Okay, so now we can say B1, okay, B1 to M, B1 to M. Here we can just go on 0, since M is connected to 0, and then M1 to B1, and I'm sure I've created there. So the connection is already established. So now let's move to serial 2. So in serial 2, B2 to B1. So this B2 here to B1. Again serial 1. So B1 to B2. B1 to B2. So here even the connection has already been established. So now let's see if this connection which you have created is okay, it is properly configured or not. Okay, so just a minute. So as you can see here underneath, you can see that it's saying successful. So meaning we are able to communicate. Okay, if I just grab a message here, this message is going from B2, from branch 2 to main. You can see here saying successful. Let me just delete again. So this message going from B2 to B1, successful. So meaning what you have created is okay. What you have created is just okay. So now we need to apply static routing. Let's apply static routing. So now having done with the frame relay, now let's apply static routing so that they can be communicating, because this particular IP address is using as you can see, this particular network is using .2. Okay, so if I try to pin in this particular network, so pin 192.168.20.2, you have seen destination unreachable. Why? Because we have not yet created the static routing, so for them to be communicating destination unreachable. So now let's use static routing. So now you can just say the commands for static routing. So for the main router, the commands will be okay. So for the main router, as you can see here, okay. So for the main router, the commands will be en conft, then we say IP route. So since I was in IPv1, IP route, then the IP address. So since we are now concentrated on main, so the main, this is the main, this one here, it is the main. So now this main needs to know about the network on branch 1, needs to know the network address for branch 1. So what is the network address for branch 1? So basically the network address for branch 1, it's 64. Okay, 64, as you can see here, 64. Okay, branch 2 network address is 128. Branch the main one, the network address is 60. So for branch 1 it's 64. For the main it's what? It's 0. For the main it's 0. Okay, so now let's go back. So here after we type IP route, then we add the network for branch 1. So 192.168.20.64. So this is the network address for branch 1, because we're targeting branch 1 at this moment. Even the subnet mask will include 192. So the next op, what is the next op? So the next op for us to reach this branch 1, it's this router here, this router. So what's the IP address for this router? So for this router, since this router it is in branch 1, we can see that the router which is in branch 1, this is the what? The IP address. Okay, this is the IP address. So this is the IP address. So we're done. So now again, this main needs to get the opposite branch 2 in this case. Let's now target branch 2. So we type again in the same router, in the main we type IP route, then 192.168.20.128. So this 128, it is the what? The network for branch 2. It is the network for branch 2. So the IP address 255.192. Now the router, the IP address of this router, the next hop is, so for branch 2 it is 195. Here you can see it's 195. So with this said, we are done for this router here. These are the commands for this router. Okay, so these are the commands for this router. Now let's create the commands for the remaining routers as well. So we start with branch 1. So don't forget that here now we're just applying static routing. So for branch 1, this is branch 1, right? So for branch 1, this is branch 1. So this branch 1 needs to have information about the main. So what's the IP address for the main? So the IP address for the main, it's .0. So this is the 0 which I have here, .0. Then the IP address, the subnet mask is the same, but the router, this router, what's the IP address for the main router? It is 93. Yeah. So here 93. Now this again, this branch 1 needs to know information, or the IP address is for branch 2. So what's the network for branch 2? The network address is 128. So this is the 128. Then the subnet mask, this is it. Then now the router going through, which is this one, which is this router. Okay, so for branch 2, which is 195. So basically we're done. So now the last one, which is branch 2. So branch 2 as well needs to know about information about branch 1 and the main. So let's start with the main. So what is the IP address for the main? The network address. So IP route 168.20.0, the subnet mask is the same. Then the next up, so it's passing. So we're in this router, right? Then we're getting information about this particular network. So the network, it is .0, as you can see here. This is the IP address. Now this router, the next up it's what? For the main here, it's .193. So here we'll just add 193. So now after we're done here, we need to come this side. So this side, what's the network for this particular network? Which is 64. IP address, the same thing, but the router, this router is passing which router? So this router for branch 1, it's 194. So here we just basically add 94. Okay. So with this said, we are done. We can now just get these commands for the main. So these commands for the main, we just paste them. We just paste the commands. Okay. So we just paste the commands. So for branch 1, this is for branch 1. So for branch 1, we just paste. Okay. So for branch 2, our final branch. Okay. So basically we are done. So now we're done with static. So let's try to pin to see if what we have done is working or not. So let's try to pin the same network. Okay, so here we're just basically trying to pin the same network. So as you can see, it is now working. We are able to pin. Okay, so this is great, because at first it was not pinning, but now we are able to pin. So we can also try to pin .130 for branch 2. Let's try to pin .130 for branch 2. Okay, so great. Now everything is working perfect. Okay, great. So now let's just go back to the question. So basically we're done with question B1. We're done, which is 10 marks. We're done. So now here they're saying include a file saver at the rightmost network. So we're including the file saver. So this is the file server basically at the rightmost. Okay, so this server connected to port 3. So this server, since it belongs to the main branch, to the main, so since it belongs to the main, so meaning the IP address will be something like 192.168.20.3, 192.3. So 192.168.20.1. Okay, so why am I saying .3? I'm saying .3 because if we look at our subnet in the main branch here, you can see that in the main branch you can assign IP addresses starting from 2 up to 62. Okay, so meaning the next to be .3. So this is why the server is .3. Now let's try to pin this server. Let's try to pin this server using this particular network. Can we pin this server? Let's try to pin. So this is .3. Okay, so here we're just basically trying to pin the server. Okay, so we are able to communicate with the server. Perfect. We are able to communicate with the server. So now the question goes on to say, use extended access control list to block the IP address .70. So .70, which is this, which is in branch 1. So .70, which is in branch 1. Then we have been given in wordcast. Okay, so from accessing the file server. So we're breaking this particular PC from accessing the file server. So when we're dealing with extended, basically extended filters traffic based on the IP addresses, based on the source, based on the destination. So the rules, so this extended as rules, even standard access control list has rules. So for extended, the rules state that we need to apply access control list as close as possible to the source. Okay, so we're applying as close as possible to the source. So this is the source. So this is where we apply extended access control list so that you can block this particular IP address or device, so to say. So for extended, just navigate inside that particular router. Then here, so we need to know the port. So this port which is connected to its port F0. So we say conft, then we say int F0/0, enter. Then here we say, here basically just say access. Okay, so access. Okay, so you can just start with the question mark. So in this port, basically you can start with the question mark. Okay, so this is the port. Okay, so we have entered into which particular interface, F0/0. Okay, so in this case we'll be supposed to enter into F0, I mean into the serial interface. So take note of this. As you can see, this particular switch is connected to this particular port, but we'll use this port which is serial 2. Okay, this port. So we will navigate in this port for us to put what access control. extended access control. So we just basically say int s2/0, enter. So here we can start with a question mark. Okay. Now just one more thing. Okay. One more thing. Just exit. Okay. So now when we're dealing with access control list, basically we're not supposed. I think we need to start from scratch. En, then conft. Okay. So here, before we even enter into the interface, before we enter inside the interface, we need to create an access list. Okay. So this is the first thing we need to start with. We need to create an access list. So we say access. Okay. Before we enter into any interface, let's create an access list. So access, then you can just say question mark. So for extended, you can choose between 10, 100 and 199. So in this case, let me just choose 110, then question mark. So we specify what we want to do. We want to deny. So we want to deny the IP. Okay. So we want to deny. Okay. So here we are saying access list 110 deny. Okay. So what are we denying? So we're denying the IP. Okay. IP. Now the source. So we just want to deny a host. So we want to deny a host. So we want to deny this particular PC. So here we can just type host, then 192.168.20.70 from accessing. So destination address. So from accessing what? From accessing host 192.168.20.3. Okay. .3. So we can press enter. So here what you need to know is that IP access control lists, they have an implicit deny all statement at the end. So for this reason, we need to write up this command, access list, then 110 permit IP permit. Okay, sorry. So permit. Okay. So IP access 110, then permit IP. Then you can say any. Enter. Okay. So this particular command will not deny any device. Okay. So after we're done here, we can now enter into that specific interface. So I'm entering into this interface 0f0/0. After creating this access control list, I'm entering this interface. So I'll just say int f0/0 enter. Then here we say IP access group, then question mark, yeah, so we selected 110, right? 110, then in. Okay, inbound. Okay, so let's press enter. Okay, so now I think everything will be okay. So show run. Okay, so here this is the commands which basically create. These are the commands. So now let's try to pin to see if it's working or it's not. If I've definitely blocked it or not. So let's pin. So as you can see, it's a destination unreachable. So meaning this is successful. We have blocked this IP address .70, okay, from accessing the file server. So this IP address .70 in this particular PC has been blocked. It has been blocked. This .70 has been blocked. So it can access .2. Okay. So .2, it can access .2, as you can see. Okay. So we have only blocked this particular PC from accessing the file server, but it can access the other devices in the same network. It can also access okay, so it's not accessing the file server .3e, it's not accessing, but it can also access .130. Okay, it can access .130, which is this one. Okay, so basically this marks the end of this tutorial. If you have any question or any comment, you can leave your comments and we can help you out. Thank you.